May 1943, North Atlantic, 400 miles south of Iceland. Kapitänleutnant Werner Henke stood in the conning tower of U-515 watching a convoy through his periscope. 23 merchant ships, 4 escorts. The mathematics seemed favorable. His Type IXC U-boat carried 22 torpedoes. Even with escort interference, he could sink enough ships to make this patrol legendary. He had done it before. His previous patrol had sunk 4 ships. This one would be even better. At 22:40 hours, he began his approach, submerged to periscope depth, moving slowly to avoid detection. The convoy escorts were destroyer escorts, smaller vessels that shouldn't pose serious threat. Henke positioned U-515 for an attack on the convoy's flank. He was 800 meters from the nearest merchant ship when everything changed. The escort suddenly turned directly toward his position, not searching, not patrolling, moving with purpose directly at his submarine. Henke ordered crash dive to 150 meters. The escort passed overhead, and then came a sound that every U-boat commander had learned to dread. A metallic pinging that seemed to reach right through the water and touch the submarine's hull. Then depth charges. Not scattered randomly as they had been earlier in the war, but precisely placed, close enough that U-515 shuddered from the concussion. Henke took his boat deeper and turned away. The pinging followed. The escort stayed overhead, tracking his every move. More depth charges even closer. U-515's hull groaned under the pressure. Light bulbs shattered, equipment broke loose. After 90 minutes of depth charging, Henke surfaced, surrendering rather than face certain destruction. As he and his crew were pulled from the water, a British sailor explained what had happened. "ASDIC, mate, we can hear you down there now. Nowhere to hide anymore." This is the story of how sonar technology transformed submarine warfare and ultimately defeated the U-boat threat that nearly strangled Britain. The weapon wasn't more depth charges or faster ships. It was sound waves that could penetrate the ocean's depths and reveal submarines that had operated with near impunity for 3 years. By mid-1943, the technology that enabled U-boats to sink 14 million tons of Allied shipping would become their death sentence. To understand how sonar defeated the U-boat, you must understand why U-boats were so effective in the first place. The submarine's fundamental advantage was invisibility. On the surface, it could be seen and attacked. Submerged, it vanished. Ships could only guess where submarines might be. Depth charges could only be dropped based on suspected locations. The vast majority of anti-submarine attacks hit empty water while U-boats escaped undetected. German submarine doctrine exploited this invisibility ruthlessly. Karl Dönitz, commanding the U-boat force, developed Wolfpack tactics where multiple submarines would coordinate attacks on convoys. The tactics worked because even when escorts detected one submarine, others remained hidden. The ocean was vast enough that submarines could attack, submerge, evade, and return to attack again. Finding a submerged submarine was nearly impossible with available technology in 1939. The primary detection method early in the war was visual, lookouts scanning for periscopes, oil slicks, or the submarine's wake. This required daylight and calm seas. At night or in rough weather, submarines operated with virtual immunity. Even when spotted, submarines could dive in seconds. By the time escort ships reached the sighting position, the submarine had vanished. Dropping depth charges at the dive position was hopeless. Submarines could be hundreds of meters away by the time explosives reached depth. The losses mounted catastrophically. In 1940, U-boats sank over 2 million tons of shipping. In 1941, the total exceeded 2.3 million tons. In 1942, it reached 6.2 million tons, the worst year of the war for Allied shipping. Britain imported most of its food and fuel. If the U-boats couldn't be stopped, Britain would be starved into surrender regardless of performance on land. The Battle of the Atlantic was existential in ways land campaigns weren't. The solution existed conceptually before the war began. Sound travels through water far more effectively than through air. Underwater sound waves can propagate for miles. If you could generate sound and detect its reflection from objects underwater, you could locate submarines that were invisible to sight. The principle had been understood since the Titanic disaster prompted research into underwater detection. Implementation proved far more difficult than theory suggested. British scientists had developed ASDIC, Allied Submarine Detection Investigation Committee, during World War I. The technology used piezoelectric crystals to generate and detect underwater sound pulses. A ship would emit a pulse that would travel through water until striking an object and reflecting back. By measuring the time delay between emission and echo, operators could calculate distance to the object. By measuring the bearing of the return echo, they could determine direction. In theory, this made submarines detectable even when submerged. The reality in 1939 was far less capable than theory suggested. ASDIC had severe limitations that made it marginally effective at best. The sound pulses were directional, meaning operators had to aim them. Searching an area required slowly rotating the sound beam and listening for echoes, a time-consuming process. The range was limited to about 1,500 meters in optimal conditions and much less in reality. And the technology was unreliable, with false echoes from fish schools, thermal layers, and geological features creating confusion. Most critically, ASDIC suffered from a fundamental limitation. It couldn't detect submarines on the surface, where U-boats conducted most operations. Dernitz's tactics emphasized surface attacks at night. U-boats would locate convoys during daylight, report positions to other boats, then attack on the surface at night using darkness for concealment. ASDIC was useless against surface submarines. The technology that was supposed to solve the submarine problem was ineffective against actual U-boat tactics. American development of sonar technology paralleled British ASDIC, but with different emphasis. American scientists focused on passive detection, listening for sounds submarines made rather than actively pinging them. This had advantages and disadvantages. Passive sonar didn't reveal the listening ship's position, but it required the target to make noise. Quiet submarines were nearly undetectable. Active sonar could find silent submarines but revealed the searching ship's location. Neither approach was fully satisfactory. The turning point began in 1942 with technological improvements that addressed the fundamental limitations. British scientists developed centimetric radar that could detect surface submarines at night. This eliminated the U-boat's surface immunity, but radar only worked against surface boats. Once submarines dove, they still vanished. The real breakthrough came from improving underwater detection capabilities through better understanding of how sound propagated in ocean environments. The ocean isn't uniform. Water temperature, salinity, and pressure vary with depth and location. These variations create layers where sound behaves differently. In some conditions, sound can bend downward, creating shadow zones where submarines are undetectable. In other conditions, sound channels can propagate signals much farther than normal. Understanding these phenomena allowed operators to use ASDIC far more effectively than when they treated the ocean as homogeneous medium. Training improved dramatically. Early ASDIC operators received minimal instruction and learned primarily through experience. By 1942, comprehensive training programs taught operators to interpret the complex acoustic environment. They learned to distinguish submarine echoes from false returns. They learned how water conditions affected detection range. They learned optimal search patterns for different scenarios. The technology didn't change fundamentally, but operator expertise made existing technology far more effective. Tactical integration was equally important. ASDIC was most effective when combined with other detection methods. Radar could detect surface submarines and force them to dive. HFDF radio direction finding could locate submarines when they transmitted. Aircraft could search large areas visually. Once a submarine's approximate location was known, ASDIC could pinpoint it for attack. The combination of detection systems created overlapping nets that submarines couldn't evade. The Hedgehog weapon system multiplied ASDIC's effectiveness. Traditional depth charges were dropped off the stern, requiring the attacking ship to pass over the submarine's position. This meant losing ASDIC contact in the final approach, forcing crews to estimate submarine position. Hedgehog launched contact-fused bombs ahead of the ship, allowing continuous ASDIC tracking throughout the attack. If the submarine maneuvered, the attack could be adjusted in real time. The Type 271 radar, introduced in early 1942, was revolutionary. Operating on centimetric wavelengths, it could detect submarine conning towers at several thousand meters even in darkness or fog. U-boats that surfaced to charge batteries or attack at night suddenly found themselves visible. The combination of radar forcing submarines underwater and improved ASDIC tracking them below created a pincer that dramatically reduced U-boat effectiveness. The intelligence dimension was equally critical. Allied codebreakers reading German naval communications could route convoys away from known U-boat concentrations and direct escort groups toward submarine positions. This intelligence, combined with improved detection technology, created situations where submarines found themselves hunted rather than hunting. The psychological impact on U-boat crews was severe. The invisibility they had relied on was gone. May 1943 represented the turning point. That month, U-boats sank 50 ships but lost 41 submarines, an unsustainable exchange rate. Dönitz temporarily withdrew U-boats from the North Atlantic, acknowledging that losses exceeded what could be replaced. The withdrawal marked the moment when Allied technology and tactics achieved dominance. U-boats would continue fighting until war's end, but they would never again threaten Allied shipping as they had in 1941-942. The statistics tell the story. In 1942, U-boats sank 6.2 million tons of shipping while losing 87 submarines, a ratio of over 71,000 tons sunk per U-boat lost. In 1943, they sank 2.6 million tons while losing 237 submarines, barely 11,000 tons per boat. The destruction rate had collapsed by 85%. The technological and tactical developments that occurred between those years had made submarine operations suicidal rather than effective. Werner Henke's experience aboard U-515 exemplified the change dynamics. In his first 5 patrols, he sank 24 ships totaling over 140,000 tons, earning Knight's Cross with oak leaves. He was one of Germany's most successful U-boat commanders. But in May 1943, improved Allied technology located his submarine, tracked it despite evasive maneuvers, and forced him to surrender after depth charging that would have destroyed U-515 if continued. The skills that made him successful in 1942 were insufficient against 1943 technology. The human dimension of U-boat warfare became grimmer as Allied technology improved. Early in the war, U-boat service offered adventure and prestige. Crews believed their invisibility made them relatively safe. By mid-1943, submariners understood they were unlikely to survive. Of approximately 40,000 Germans who served on U-boats during the war, about 30,000 died, a 75% casualty rate. No other military service in any nation suffered comparable losses. The psychological pressure of being hunted by invisible forces was crushing. U-boat crews could hear ASDIC pinging against their hulls but couldn't see the ships hunting them. They knew depth charges would follow but couldn't predict when or where. Some attacks lasted hours, with submarines at maximum depth while their hunters maintained contact and methodically depth charged them. The experience drove some crews to psychological breakdown. German attempts to counter Allied sonar were largely unsuccessful. Rubberized coating called Alberich, designed to absorb ASDIC pulses and reduce echo return, proved marginally effective and was difficult to maintain. The snorkel breathing tube allowed submarines to run diesel engines while submerged, reducing surface time, but the device created detectable wake and reduced speed. Acoustic torpedoes that homed on propeller noise achieved some success, but couldn't reverse the fundamental technological advantage Allies had gained. The Type XXI U-boat, introduced late in the war, was designed specifically to operate submerged for extended periods with high underwater speed. If deployed in numbers, it might have restored German competitiveness, but fewer than 120 were completed before war's end, too few and too late to affect the outcome. The submarine that could have countered Allied sonar appeared when Germany lacked resources to produce it in meaningful numbers. The strategic implications of Sonar's success were profound. Britain's survival depended on Atlantic supply lines. If U-boats had continued sinking shipping at 1942 rates, Britain's ability to prosecute the war would have been crippled. The Allied invasion of Europe required moving millions of tons of equipment across the Atlantic. Without control of the Atlantic, D-Day would have been impossible. Sonar technology, combined with radar and intelligence, enabled the victory in the Battle of the Atlantic that made everything else possible. The post-war legacy of wartime sonar development shaped naval warfare permanently. Submarines became nuclear-powered and could remain submerged indefinitely, but they remained vulnerable to acoustic detection. The Cold War became competition in submarine quieting versus sonar sensitivity. Modern submarines use elaborate sound dampening systems to avoid detection. Modern sonar uses sophisticated signal processing to detect extremely quiet submarines. The fundamental dynamic established in 1943, submarines hiding acoustically, surface forces hunting them with sound, remains central to naval warfare. The scientists who developed improved sonar received less recognition than weapons designers, but their contribution was equally decisive. They transformed ASDIC from marginally effective to submarine-killing technology through incremental improvements in electronics, better understanding of ocean acoustics, and integration with other systems. None of their innovations were dramatic breakthroughs. All were essential to achieving the cumulative effect that defeated the U-boat. For the U-boat crews who faced improved Allied technology, the experience was transformation from hunters to hunted. Early war patrols had involved attacking merchant ships that couldn't fight back, with escorts that couldn't find them. By 1943, every convoy was defended by escorts that could detect submarines at range, track them continuously, and attack with weapons that didn't require breaking contact. The confidence that had characterized early U-boat crews gave way to grim determination among those who understood survival was unlikely. The final U-boat losses in April and May 1945 occurred as Germany collapsed. Some submarines surrendered. Others were scuttled by their crews. A few attempted to escape to Argentina. But by war's end, the U-boat force that had nearly strangled Britain had been destroyed by a combination of improved technology, better tactics, superior intelligence, and industrial capacity to produce detection equipment faster than Germany could build submarines. When historians assess technologies that shaped World War II, they typically focus on radar, nuclear weapons, and code breaking. Sonar receives less attention despite being equally consequential. The Battle of the Atlantic was the only campaign that genuinely threatened Allied defeat. Losing it would have made winning the war impossible. Sonar technology, refined and deployed at scale, ensured that Britain remained supplied and that Allied forces could project power across the Atlantic. Werner Henke, the U-boat ace whose submarine was forced to surface by persistent ASDIC tracking in May 1943, survived the war as prisoner. In post-war interviews, he acknowledged that by mid-1943, U-boat operations had become nearly suicidal. The technological advantages U-boats had exploited early in the war had been countered. The ocean depths that once provided protection had become trapped as Allied vessels above tracked submarines below, with sound waves that penetrated darkness and depth. The metallic pinging that U-boat crews learned to fear represented more than just technology. It represented the moment when Allied scientific and industrial capacity achieved decisive advantage. Sonar didn't win the Battle of the Atlantic alone. Radar, code-breaking, escort carriers, long-range aircraft, and industrial shipbuilding all contributed. But sonar was the technology that turned submarine invisibility into submarine vulnerability. Once submarines could be detected, tracked, and attacked while submerged, their fundamental advantage disappeared. And with it disappeared Germany's best chance to win the war through strangling Allied supply lines. The lesson was clear. Technological advantage could be temporary. Germany's early submarine superiority came from exploiting invisibility. When Allied technology could penetrate that invisibility, the advantage evaporated. The U-boats that had terrorized Allied shipping became targets themselves, hunted by escorts using sound waves to reveal them. The Battle of the Atlantic was won not through courage or numbers alone, but through technology that made courage and numbers applicable. Sonar provided that technology, and in doing so, defeated the U-boat.